Hey everybody, welcome to Proving Ground. A special thanks to Versprite, Protiviti, Tenable, and Amazon, and Source of Knowledge for helping us be here. And would you like to take over?
Ladies and gentlemen, hackers and mundanes. Okay, that's better, right? That's right. Okay, who here does not appreciate modern plumbing? Oh, okay. Does not appreciate it? Okay, well, then I never want to go near your hotel room because you've never flushed. We're going to get started today listening to the incredibly intelligent Ash. I signed up to mentor this talk. Like, okay, good, I work in some related stuff. I'll be able to help this person. No, it ended up being, I was like, crap, I got to write this down and do this stuff. So, without anything further, Ashley Holtz talks about automation plumbing because everybody needs to flush their data.
Do a speech. So I do automation stuff primarily in my job, so I'm going to give us a talk about my job, which will be fun for all of you. So I'm talking about plumbing. I'm not talking about IR tools and which ones are good, which ones are bad. There are a lot of people who know a lot more than I do about specific artifacts, so I don't want to write my own thing most of the time. Sometimes I do out of necessity, but usually it's actually connect the things. So I'm doing a connect the things talk and some ways that we can do that a little bit better. There are a lot of great tools available already. They don't connect well out of the box, and I eventually want to see people waste less time running stuff over and over again. So here is my ideal workflow for a SOC. So think about this in terms of you're in your own company. This is not in terms of like me being a consultant going out to 50 different companies. This is inside of your own company. Ideally, you find out that there's something going on some endpoint. And you figure that out through some user report, through some SIM, one of your 500 things that you already purchased in your environment. Who owns 500 things? I certainly do. Yeah. So you put it in a queue. We have some metadata that's common to all of these things. If there's something going wrong, you probably know the IP address of where it's going wrong or the host name, I would hope, because otherwise how are you going to remediate it? You should know some information around the event, user, what type of alert it was, and it should go in a queue. From the queue, you should be able to say, okay, you have your level 1 guys usually, and they're going to say this is BS, this isn't BS. So if it is a false positive, you want to be able to adjust your detection rules. And I have adjusting detection rules in a couple of different places because once we learn more, we always want backward propagation, and that doesn't always happen in a lot of security settings. We're going to wait for somebody to give us new signatures or something. And does that work well for anyone ever? Not really. So if we find new things, we want to learn more about the things. So once we've gotten to the point where this isn't BS, we want to investigate this further. Ideally, I would have an analyst who can hit the button and say, run these commands that I would probably run. So if somebody clicked on a link from a phishing email, I want to say, oh, okay, let's see what outgoing connections are happening. Let's see what's running on the box right now. So like what, netstat? I would want to be able to do that remotely. So that's what I mean by triage metadata command output. So commands are the commands that if I were sitting on that person's box, what are the things that I would type on that box? And then metadata would be things that we can easily query from a built-in API. So Linux is very friendly to us. We can usually get most of the things from the command line. Windows doesn't work that way. Sometimes we have to open up C# and hook some kind of Windows API, whatever. Sometimes from there, you need to pivot and collect a little bit more. So I want to connect a range of events from an MFT instead of just, I want to know that this thing is on the box. I want to know what else hit the box at the same time. I want to see a journal. I want to see a bunch of other things. So that's artifacts, forensic artifacts for people who do IR in here. Sometimes we want targeted network capture. I put those on the same level because it's either pivoting into getting more information about network comms in general. Like, okay, we know this bad IP address is being called out from this box. Let's see if anybody else is calling out there. So it's getting more information that way. Or it's I'm getting specific files from this specific host based off of some bad thing that I found. And then from there, you might want even more targeted files. Like, let me get the actual piece of malware, which there aren't a lot of endpoint agents that let you just willy-nilly pull a file that you feel like pulling. But they shouldn't do that because that's not very safe. And you can debate that with me over a beer later. So once you have all of that information, the last piece and the most important piece, at least for me, is standardizing and aggregating, being able to put them into a central location. Because I don't want to just say, here's the outputs from 50 commands. You need to learn how to look at these 50 different things. No, it should all be in one place. It should be really easy to query. It should be so simple that you hit a button and you find evil. Laugh at my joke. There's no find evil button, come on. Nothing can replace a good analyst. And that's another reason why I call this the plumbing piece of the automation. This is not analysis automation, because otherwise I wouldn't have a job if we could automate the analysis away. Sometimes you just want to parse something. So Linux web servers, they give me nice logs. There is a nice way to parse those. Many established open source and commercial products can do that, whatever. Sometimes we need to process them. So something that's stored as like binary clusters, something that's stored as some like decently well-documented artifact. Like we know a lot about prefetch files, but if you just open one up, it's like, the heck is this? And then if we wanted specific files, do we want to store malware executables just in a file server? No, the malware analyst says yeah. But I usually want to obfuscate those and code them somehow, just store them as a blob, who knows. But I want to have a place to store that stuff. So I figured out there's something going on in this box, it's weird. I get more information. The types of information I get should be aggregated in some sane way. And if you wanted to write your own tool as an analyst, you can say, okay, I can hook into this, I understand the output, I can do more with it, I can write rules to look for evil things that I know about, or I can just download the results from specific tools. And there are a lot of tools that do this, or you can make your own tools. So I'm giving you a make or buy decision here for the one business major in the room. Yeah. So buy doesn't mean you're shelling out cash for this. Buy means somebody else made this thing, and you're just using it. So a well-documented open source project that's been community vetted. Why don't I say, oh, just find some code on the internet? No. No, I'm saying well-documented open source project. That's why I call it something that you can buy. It's something that's already been vetted, something that's relatively well used. So the other piece of this is you can make these. So if you have an in-house programmer like me, you can say, Ashley, go code the things. But not all of us have that, and not all of us have somebody who has time to do all of that. So there are ways to do a lot of these things. But the last piece, that artifact analysis automation, and some of the processing around that, there isn't something that will run everybody else's tools, and there's not one thing that processes all the things. And we don't necessarily want one thing that processes all the things. One tool to rule them all is not the right way to do this, because one creator is not going to know how to process all the things the best way necessarily. So for processing automation, this is after we've gotten artifacts out, after we've gotten all the metadata, whatever. The most automatic, on-demand, fast way would be containerized, clusterized processing. We have lots of machines working in parallel, super simple. Maybe they're all running the same process, and you've got this queue that feeds them. That would be so nice to have and so usable, but we don't usually have that. A lot of companies are actually way down here. They've got a local VM. You're on your MacBook here, you spin up your SANS/SIFT, and you run all the tools that you spent a week learning how to use manually. Well, that's great, and if you want to bill lots of hours, that's a really good way to do it. But if you want to provide a product that's useful, wouldn't it be great if you could just get the results out nearly instantaneously and then have all of that and spend those 6 hours doing analysis instead of running tools? I think that's a good way to do it. Some of the for-profit distributions, I'll call them for-profit, Xways on Case, they have processing for some artifacts built in, and you can extend those as well. I don't consider that necessarily heavy automation, and I don't put it very high on the scale because, again, it's one creator, and you still have to plug things into it. So I'm going to show you a couple of plumbing solutions that I use, and I'm very open to healthy debate, but I do have a lot of material to get through, so I'll ask you to save questions, comments, concerns till the end. So CrowdStrike has a crowd response freeware tool. Not trying to sell you anything. You know, I don't care if you use it or not, but I like it okay. We also have Python scripts that we use internally. We have APIs that we use to insert stuff into databases. So I'm going to show you what step of this workflow each of these things would live on. And I'm also going to release these slides along with that GitHub repo that I had on the first slide. So you can mess around with this as well. Some of this is super hacky. This is super hacky. So many collectors, including crowd response, have a place for a configuration. You can embed a configuration in crowd response. Well, the way to automate that is to use Resource Hacker and replace the resource where that config is with your configuration. I gotta cringe. Yeah, super hacky. So before we deploy crowd response, it does run a lot of things that you can get through the Windows API. And it outputs things that you would get from running commands on that machine. It's just a bunch of them all in one distribution, and it's a fairly small binary, which is why I like it. And you can write a text configuration and embed it there. So this would be this metadata triage, kind of the first thing that I would deploy. It's not a get all the things. It's not a get a full triage image that'll take us forever and be giant and move over the network. We don't want to deal with that quite yet. So this is just a little easy tip. You have to be very careful to read the EULA of the binary that you're modifying. Do not just open up crap in Resource Hacker, replace things, and deploy it in your environment. Read the EULA. None of you are going to read the EULA. That's okay. The next piece of this is image processing. So if you have a hard disk image, which we occasionally get, or if you're writing something that's going to run on the machine and actually get out forensic artifacts, as opposed to stuff that you would run a command to get the information. So I wrote a quick dirty extractor to demo how to do this. There are a lot of things that can extract artifacts. I'm not saying this is the best way to do this. It's something to demonstrate a point. And my point, so you can't get the metadata, you can't get artifacts, and you can't get individual files. My point is that I want sane parsable JSON output from every piece of the stack. So how many of you have encountered a really great forensics tool that does not give you sane parsable output and you have to write something else to process the thing? Thank you for writing the tool. Like, that's really solid of you, and giving back to the community is really great, but let me use it. So XML is fine too, but I really like JSON. A lot of our automation is in Python. JSON converts pretty easily into a Python dictionary, so that's why I choose JSON. But really, sane parsable output that everything can process from start to finish is so nice, and it makes my life so easy. And a lot of the automation I end up coding is, how do I make this thing able to be inserted into another thing? And I spend a lot of time doing that, and I don't want you to have to spend time doing that. So the little collector that I wrote basically puts all the files in a single folder and then has this JSON manifest. And this is probably quite small print, but you can see this rule field. So EVTX, this is a new style event log, right? So the rule that triggered this is the kind of thing it is. I don't have to read the first couple lines of the file to see what it is, which is nice. We have a hash of it. A times, C times, so MAC times, sizes, which data stream it was, because sometimes we have alternate data streams, and if I'm going to write a parser to go against this, I want to parse the right data stream. So it makes my life a lot easier to have that. So if you don't have sane parsable output, please code sane parsable output into your stuff and save somebody like me a lot of time. The other piece of this is processing automation in terms of using other people's stuff to insert your things into some big data solution. I like the Elk Stack pretty good. A lot of people use the Elk Stack. Logstash is fairly friendly for most types if you can write a good Logstash configuration for it. But the main thing here is, if other people's stuff can't pick it up easily, you're doing something wrong with your output. So this is part of the standardizing and aggregating and the processing and parsing piece of this. So usually our executables are our tools for parsing pieces of our images or parsing specific artifacts. They come in two flavors. Here's an executable. It's freeware, like crowd response. We're not giving you the source code for this, but you can run it. Or there's a Python library. So how do I make everybody else's Python library runnable in a standardized way? Well, here's the answer, at least the one that I came up with. Just a basic interface type of object. So Python doesn't necessarily have a straight up interface class. I just create a runner class, and you can inherit that runner class. So I have a very simple init. You take in an input and an output, and then run the actual Python library. So this is more of an automation piece, and it's running other people's code. The reason behind this is I don't want to have 50 different rules, like event logs. There's about 20 different tools that exist that parse those. Do you think it's all somebody else's tool.run to process it? No, they're all completely different. But if you can standardize it this way or modify the source code and then contribute it back upstream to fit into this paradigm, it's going to make it a lot easier for other people to run it and integrate it. So just simple class. So I have a run method and I have a quit method. Elasticsearch and Splunk plumbing. How many of you use Elasticsearch? And how many of you use Splunk? And how many of you don't want to talk about this? So I have a couple of treats just for B-sides and everybody else who's going to watch the video, I suppose. I did create a Logstash configuration for crowd response. So for the output, after you run the conversion tool, it takes in the CSVs. And I also released a configuration for crowd response. So remember that resource hacker bit where you can embed a configuration in there? Here's the configuration that you embed. Of course, we're going to test this first before we implement this in a production environment. Yes, we all look like trustworthy people. None of you do. So the latest crowd response is on CrowdStrike's community tools page, freeware, have fun. For Logstash, don't try to use the Elasticsearch API to convert your data and insert it. I made this mistake fairly early when I started doing automation engineering. Don't try to use an API that just sends events through a socket. That's going to be much slower than using tools that are created for listening and throwing events in. So like Logstash, for instance, you can have multiple workers going at a time. It's not just going over this one socket and possibly just randomly closing sockets. So don't try to reinvent the wheel. If there's a thing that can ingest data, twist your data to fit the thing that will ingest it. I know this sounds completely logical. I spent a long time remaking Logstash, essentially. Also with Logstash, if you specify column names and mutations for data per type, I usually do based off of the file name, it's going to make your life a lot easier, and it's actually going to process a lot quicker from the experiments that I've done. And now for something really hacky. So this is my gift to you. My mentor, Kyle, asked for a graph. Here's a graph. Man, bar chart. So there is a Splunk SDK for Python, and it is streaming sockets. It works pretty well. It's well documented. I found out a much faster way to download results from Splunk. So one of the automation steps that I get asked to do a lot is download stuff from Splunk based off of this query and then do other processing on top of it that's going to be slower or inefficient in Splunk. So my preference is to do this direct download approach. The code is on my GitHub. I'm not going to walk through it because, well, I don't think you want to sit here for 20 minutes and watch me walk through code. Right. So when I tested it, it's much faster. If you want to test it and give me your test results, I would appreciate seeing those. I also gave the benchmarking Python file, so you can actually run this benchmark yourself and say, Ashley, you're full of crap, or yeah, that's true. So please have fun with it. The last thing that I really want to say is the automation plumbing. A lot of people don't think about this when they go into incident response or forensics. They say, oh, well, we're going to have a bunch of tools, and we're going to train our people to run those tools really well and interpret the output of these 50 different things. And that's great for helping people understand what the artifacts are, how they work. But after you've been doing it for a couple of years, hitting go on 50 different tools is very irritating. So with the combination of writing Python wrappers around other people's Python libraries, which I have an example in the repo, or creating output that's usable in other places, so like that JSON output, will really make your life a lot easier in terms of automating the analysis steps that I think do lend themselves to automation, like statistics. And then the other thing too is if you're putting everything in a standardized place and you're doing hunting today, that back propagation, if I find something new today, I also have a bunch of data from previous runs. So if I find a new evil thing, now I can go back into the old data and say, okay, well, now let's see if that old data existed elsewhere. Maybe we have more to remediate than we thought we did. And you can see, oh, well, that's actually been here for 2 years. We're just seeing it now. What the F? Standardizing in general will speed up processing, but really for me, as the programmer in a room of consultants most of the time at work, I want things to be maintainable. These guys love to create scripts, and I like it when people create scripts. I like it when people contribute things to the open source community. That's very important to me. But make it so that somebody else can reuse it or plug it into their project too. Sane output should connect all of the processing steps. And there are a lot of community vetted tools and workflows. There's GUR, there's Autopsy, there's Plazo Log to Timeline. There's so many things, like meta projects, I'll call them, that can do a lot of forensic things. And to make use of them most effectively, along with those little one-off tools that are really good individually, you have to write a few plumbing steps. So hopefully that answers what automation plumbing is. Hopefully now you have a better understanding and appreciation of modern plumbing. This is where you laugh at my joke again.
Yeah!
This is a good joke. And hopefully some of the code that I've released will be somewhat useful to you. I'm happy to talk about this all day. This is my job, so if you've messed around with any of this stuff and you'd like to tell me better ways to do some of this, I'd absolutely love that. This is my Twitter handle. I'm the Code Monkey. I have my GitHub repo. And I'd like to say thanks to Kyle Maxwell. He was my mentor for this. And I would not have had the confidence to come up and talk to you today without the mentor program and Kyle. So if you see this guy, give him a high five or buy him a beer. Yes.
Questions? Questions?
Yes.
Yeah.
I know the Intel announced an initiative where they wanted to get together with other security vendors and have people start writing to common APIs and to orchestrate better. Do you know about that, and can you comment about where that progress is going or what your idea on that is?
I mean, I'm not involved with it. I like that people are talking about it. But especially, let's go all the way back through the slides. So you see where you have all the things, this alert aggregation. I would really like somebody to write just a nice open source, out of the box, ready to use aggregator and queuer or assigner. That would be really nice to see if I were to pick where that would go. And then these little glue pieces between different forensic tools would be really cool to see. So.
It's like most of what it's going to do is just take existing vendors and try to make them work together and not necessarily go with open source.
Yeah, and I mean, that probably wouldn't be my favorite approach for it. I like to give things away, open source style. I like people to criticize what I put out. And I do think forensics in general, it kind of does lend itself to open source examination because just because I've observed something 20 times, maybe you've observed it one more time and it looks different and acts differently from how I've interpreted it. So I don't like, I don't like saying that it should be one closed source opinion, but yeah, that's super cool. Yeah.
In your workflow steps, I don't think
Sure.
that the more data step or the feedback loop has to mean that folks like us lose our jobs, but I'm just interested to know, have you experimented with automating this feedback loop to improve the tool based on whatever data you're getting back about, yeah, this is real, this is fake?
Yeah, so we actually have. It's usually just feedback from an analyst, and they'll say, yeah, this makes sense, this actually was bad, and then that will get fed back into like a hash table or something like that. If I were to have like my own SOCs, I'm in consulting, so I can't really go and just collect random things from a bunch of client environments for fun, but if I had my own SOC where I was just writing all of this individually, I would love to build automation around, okay, once on this workflow step, the analyst has checked that this is bad, and this particular line of output is where we found the bad thing. Because it's standardized, perhaps we could take a path pattern or all of the information that's associated with that and put it into the bad area. But yeah, I, in mass, have not been able to experiment with that. Just informally, have a little bit.
You guys have any questions? Anybody? 3, 2, no? Okay.
Okay.
Well, thank you, Ashley.
Thank you, guys.